Welcome class. Thank you for joining me for our beginning of chapter 10. Before we dive into the bulk of the material, the real meat of the material, we're going to focus on some little pre-activities first. This entire unit is going to be based on radicals. And when you hear radical, what I want you to think is square root. A radical is a square root. Okay? Now, when you take the square root of something, basically what you're looking for is what number times itself gives you this number. So when you're looking at this one, when you're looking at the square root of 4, you're looking for what times itself gives you 4. Well, plug into the calculator, you get 2. For this one, what number times itself gives you 81? Well, 81 is 9 times 9. Square root of 256. What times itself gives you 256? Well, 16. Now, do realize you can do this on the calculator. Okay, for these nice ones, so all the ones in this first group, you can actually just plug them into the calculator and it'll give you the answer. So square root of 121 is 11. Square root of 324. Now for these bigger ones, you may not know it. So this one especially, make sure you type in so you're getting it right. You should get 18. Square root of 1 is 1. Now, these fractions get a little bit more interesting. However, all you really have to know is when you square root a fraction, you basically can take the square root of the top, so you get 8, and square root of the bottom, where you get 9. Same thing in number 8. Square root of the top gives you 1. Square root of the bottom gives you 4. Square root of 9 gives you 3. Square root of 100 gives you 10. Square root of 25 gives you 5. Square root of 49 gives you 7. Now, these are obviously the very nice cases, because you know from experience, square roots don't always turn out to be nice, don't always turn out to be friendly. Now, we are going to talk about simplifying non-perfect squares now. And the first thing you need to know is the first 10 perfect squares. I'm going to need you to memorize this list of numbers. Okay, you need to know all 10 of those numbers like the back of your own hand, because that's going to make it easier when it comes down to simplifying these expressions. Now, the key here is this right here. The fact that we can break down square roots, okay? So what this means is the square root of a number is the same thing as square rooting two things that multiply it. Now, why might this be important? Well, it's important because if we can pull out a perfect square from a radical, it means we can simplify it. So, for example, number 11, we're trying to find the square root of 24. Now, if you type it into your calculator, you can see you kind of get back number vomit, okay? This is one of those not friendly cases. However, if you're looking at our list of numbers that we just made, look to see what is the greatest one that divides that 24, okay? And what I'm seeing is 4 divides the 24. In fact, it is 4 times 6. Now, why did I have to choose a number off that list? Well, the reason I had to choose a number off that list is because the square root of 4 is something that we know. The square root of 4 is simply 2. And so, in math, we consider this to be a reduced radical, a simplified radical, okay? And that's the form I need you writing your answers in. Now, number 12. So looking at that one, now this is where you have to start being very careful because as you're looking at your list, you may see, oh, awesome, 4 goes into 48. However, notice that we are always looking for the greatest perfect square. So I emphasize greatest because you don't want to actually pull out the 4. What you want to pull out is the 16. 48 is 16 times 3. And when we pull that out, square root of 16 becomes 4. And then we leave the square root of 3. All right, number 13. So square root is 72. So again, we're looking for the largest number. Again, as you look at these numbers, you may see that 9 goes into 72. However, realize that there is something bigger, something larger. You can actually break this down into 36 and 2. Square root of 36 becomes 6, and then you leave the square root of 2. Now, let's suppose we didn't realize that. Let's suppose that we used 9 and 8. Well, square root of 9, square root of 8 leaves us 3 square roots of 8. Now, notice though that 4 goes into 8. So what you end up doing is you're getting something that you would actually have to break down a second time to fully simplify it. So that's why you can tell we don't want to do this. You always just want to look for the largest perfect square that divides our number. So 14, as we're running through our list, what's the largest perfect square that divides 90? I see 9 times 10, because that'll reduce into 3 square roots of 10. All right, let's flip this over. Let's work on the next page. So again, now we're starting to deal with slightly bigger numbers. However, you can still focus on the original list of numbers that we were looking at. So 175. While looking at that, I think 25 will probably go into that. In fact, it is 25 times 7. So looking at that, that becomes 5 square roots of 7. Number 16, the square root of 162. All right, so let's carefully look at this one. So 162, let's see. Well, 4 doesn't divide it. So I'm going to try 9. Oh, 9 divides it. But let's see if there's something bigger. So let's try 16. Nope. Let's try 25. Nope. Let's try 36. Nope. Let's try 49. Nope. Let's try 81. Oh, there we go. It's 81 times 2. So again, the strategy when you're dealing with these bigger ones, when it gets more difficult to see, I would just start running through that list. Take 162, start dividing it by each of these perfect squares. See which ones, when you divide it, will give you a whole number. Because now you can say this is 9 square roots of 2. All right, 117. So 117. I think it's pretty obvious we'll not divide by 4. It's not even an even number. So let's try 9. Well, when you divide it by 9, you get 9 and 13. And square root of 9 becomes 3. So you get 3 square roots of 13. All right, number 18. So 245 divided by 4, nope. 245 divided by 9, nope. 245 divided by 16, nope. 245 divided by 25, nope. 245 divided by 36, nope. 245 divided by 49, oh, there we go. It is 49 times 5. So this reduces to 7 square roots of 5. All right, square root of 150. So this one, I'm hoping you guys can see, 25 goes into 50 very nicely. So this is 25 and 6, which reduces to 5 square roots of 6. All right, so number 20. Number 20 is a little special because I want you to notice this time there's a number out front. Okay? Now, what we do with the number out front is we kind of carry it through the problem. So 300 breaks down into 103. So we get 2 and 10 square roots of 3. So when you have that number out front, what really ends up happening is it ends up multiplying whatever you pull out. So 2 times 10 gives me 20. So all it really does is carries through the problem and multiplies that number that you're able to pull out. And looking at 21, well, I think 21, we can see 9 pulls out of that. So square root of 9 times square root of 7, so we get 3 square roots of 7. And now 216 is another one that we're going to have to go searching for. So 216 divided by 4 gives us 54. Now we found one, but let's make sure that there's not a bigger one. So 216 divided by 9 gives us 24. But again, let's see if there's a bigger one. So 216 divided by 16, nope. Divided by 25, nope. Divided by 36. Okay, now 36. When we divide by that, we get 36 and 6. And so notice that square root of 6. There's nothing we could pull out of that. There's no perfect squares left in it. So that means that we're done searching. So this just becomes 6 square roots of 6. All right, so I thank you so much for joining me. So please make sure you have all of these notes written down, and then we will work on our practice work in class.